Hey everyone, welcome back to another episode. So last video we got the fixed function stages set up for the graphics pipeline. Since we finished up the programmable stages before that, we can actually move on to creating the pipeline itself. And the good news is all this hard work is about to pay off. I'm thinking that in the next video we should actually get something on screen finally. So it may end up being a long video, but we got a few more things to finish up in this one before we get there. Anyways, let's get right into it. So the last thing we need to do before creating the actual pipeline itself is we need to set up a render pass. Our render pass is just processing the data that we have to render a single image, and you'll have tons and tons of render passes all running over and over to eventually give our scene something physical that you can see constantly. So we need to set up a function for that. Let's hop over to planetvulkan.h, and we're actually going to need to create the render pass before creating the graphics pipeline. So we're going to say void create render pass. There we go. And we're just going to take that, copy it over to our CPP. Now, like I said, we want to drop that right before CreateGraphicsPipeline. And of course, we're going to pull that void off because I'm just copying and pasting, which is terrible programming practice, but I'm lazy. And we're going to drop down here, and right before CreateGraphicsPipeline, we're just going to go ahead and define this, and of course give it the proper scope so it knows that this is part of the same class. So there we go. We have our create render pass. Now we need to actually have a render pass object. So we're going to hop over to .h again. Whoop, going the wrong way. Oh, maybe I wasn't. Here we go. Alright, and let's do it right before the pipeline layout. We're going to go ahead and, once again, this needs to be wrapped in a vDeleter because it is a Vulkan object. So vDeleter, and the type is going to be a VK render pass. There it is. We'll just go ahead and call it render pass, and we're going to pass into it, as usual, we need the logical device, and we need a delete function, which is going to be a VK destroy render pass. Alright. Oh, render pass. Render. There we go. Much better. Alright, so let's hop back over to the create render pass function. And to create it, we're going to use a VK create render pass. And as usual, we're going to set this up the same way we always have in an if statement. If, and it's going to be VK create render pass. And then we pass in logical device. Nope, not create logical device. There we go, logical device. We're going to need to pass in a reference to a render pass info. This is what I'm going to call it in a second. We're going to work backwards as usual because it makes more sense that way. A null pointer for the p allocator, and then render pass dot replace once again because we're using vDeleter. And then, as usual, we check if that's equal to VK success. Okay. If it's not, we're going to go ahead and throw std runtime error, and we're just going to say failed to create render pass. And if it succeeds, we would like to know. So we just say std cout render. There we go. Pass created successfully. Perfect. Alright, so that's everything we need to create it, but now we need to pass in that render pass info. So let's go ahead and get started filling that out. So right up above this, we're going to make a little space, and we're going to declare a new VK render pass create info. There we go. We'll call it render pass info, so it matches up with the one that we declared down below. There we go. And now we need to fill out all its data. So as always, there's a render pass S type, and in this case it's going to be a VK structure type render pass create info. Makes sense. Good. Now we need to fill out the data for attachments and subpasses. Now we don't actually have this data yet, but we're going to just fill it out and then move backwards and get everything as we go. So what it's expecting a render pass info. There's attachment count, and we're going to come right back to that. Render pass info and p attachments, which is going to be pointers to all of the attachments that we're using. Then render pass info subpass count, and render pass info, and you guessed it, p subpasses. Now for both the attachments and the subpasses, we're only going to be using one. Okay, we're about to get into that a little bit more. And here, let's put that back where it needs to be. And for the pointers, we're going to create a color attachment and subpass to reference for those. So I'm just going to go ahead and, even though we haven't declared them yet, pass in a reference to them, and then we'll just move right up above and declare those. So color attachment, subpass, and now it's expecting those. So let's move up a little higher. So we're going to start with the attachment. Like I said, we're only using one, which is going to be a color buffer attachment. And in this case, it's going to be one of the swap chain images. So we need to declare a new VK attachment description. So VK attachment description. We're just going to call it color attachment. So now it'll stop yelling at me down there. Okay. And we need to set its format. So it's going to be color attachment dot format, and we're going to set this to the swap chain image format because we want them to be the same. We're going to set a sample amount for it, so color attachment samples, and in this case we're just going to set it to VK sample count 1 bit. Yeah, and the reason for that, using more than that would mean that we were using multi-sampling, which is for anti-aliasing, and that won't be necessary when we're just drawing triangles. So for now, we're going to keep it simple. Maybe we'll come back and modify this later on. So next up, we are going to need the data for load op and store op. So it's going to be color attachment, load op, and color attachment, store op. So what these two do, load op decides what to do with the data in the attachment before rendering, and store op handles what to do with it after rendering. So we're going to set load op to its VK attachment load op clear. So what that's going to do is it's going to clear the frame buffer to black before we render. And then for store, we're going to set it to VK attachment store op store. And so what that does is it means that the image will be stored in memory to read. If we don't put store, then we won't have an image to render. So that's really the best option here. Next up, we are going to need a stencil load op and stencil store op. So this affects stencil data. What a stencil buffer allows you to render to it and then stencil out parts of the regular frame buffer with what is in the stencil buffer. So a good example of this, if you had a security camera in a game and you needed to render in like a security room what that camera saw onto a TV, the camera's image could be written to the stencil buffer and then stenciled over that TV's surface when you're in the security room. Hopefully you found that info informative. We aren't going to be using a stencil buffer, so that whole explanation was interesting but pointless. So we're just going to go ahead and go to color attachment, stencil load op, and we're going to set it to VK attachment load op don't care. It's pretty descriptive there. And color attachment Stencil Store Up equals VK attachment store. Don't care. There we go. Alright, and last up we need to specify the layout of the images before and after the render pass. So for color attachment, we have initial layout, and that's going to be VK image layout undefined. That just means that we don't really care what type of layout the image is in when it's passed in. When we're passing the final image out, we are going to want to make sure that it is passed to a swap chain, so we want it to have the same format. So we're going to say color attachment final layout equals VK image layout, and it's going to be present src khr. There we go. So now that we have that, we need to fill out the subpass info. We still haven't gotten to that. So let's go ahead and fill that. So just to explain the subpass a little bit more, the subpass allows you to do additional rendering operations on a single render pass. You can have multiple subpasses. We're only going to have one for now. So we're just going to declare a new VK subpass description. There we go. Call it subpass. So now, hopefully, yep, there we go. The render pass create info will stop yelling at us because we have everything declared. We just don't have the information filled out. So we need to indicate what type of subpass this is. So we have a subpass, and it's going to be the pipeline bind point. So we're going to indicate that this is a graphics subpass. We're going to say VK pipeline bind point graphics. There we go. Now the subpass needs a reference to a color attachment, the one that we made before, but we can't pass it in directly. We make a VK attachment reference for the color attachment. So let's do it right above it, right here. We're just going to make a VK attachment reference. There we go. Let's put a little space between these. VK attachment reference, we're going to call it color attachment ref. There we go. And let's see. We're going to set the color attachment ref. There's attachment. And we're going to go ahead and set this to 0, which is the index of the attachment that we want to reference in our attachment descriptions array. And we only have one attachment description, so index 0 gives us the color attachment that we made. And then we need to set up the color attachment ref layout. And this is going to be VK image layout color attachment optimal. That means we're using the attachment as a color buffer, and we want optimal performance. So that's everything we need for that. So we can drop back down to our subpass again. We can say subpass color attachment count. It's going to be 1 because we only have one. And we're going to say subpass, and of course there's p color attachments. So we need to pass in a reference to the color attachment ref. So reference color attachment ref. Here we go. So now that we have all of that, our render pass should be created successfully. Let's take some of the white space out of here, make it readable but not ridiculously large. That's a bit better. So let's just give that a quick run and see if we get our render pass. No point in moving on if things are broken. Give it a moment to boot up here. Come on, you can do it. I'm not a very patient person. Any minute now. Hypnotic spinning wheel. Alright. Let's see what we get. And there it is. Render pass created successfully. Ooh, looks like I left off a end line there. So let's fix that real quick. Everything's working fine. It just, I don't like my output being ugly. So we'll just tack on right here, std, end all. There we go. Much better. So let's move on to actually creating the pipeline now. We're finally there. We have this create graphics pipeline, but we never actually created a graphics pipeline in it. We set up all this data for it, and we created the pipeline layout, but there is no pipeline. So let's actually get to that. Right under the layout, we're going to go ahead and set up a VK graphics pipeline create info. So it's going to be, like I said, VK graphics pipeline create info. There it is. We'll call it pipeline info. All right, and we need an S type, which is going to be a VK structure type graphics. There it is, graphics pipeline create info. Love that it fills things out for me. And now we have a pipeline info stage count, and we're going to set that to 2 because we have 2 programmable stages that we defined. That was back in episode 8. And then we need to pass in pipeline info, and it's going to be the P stages. So once again, we have a count, and then we say what they are. And we're just going to pass in shader stages, which we declared right up here. Where is it? Right here. VK pipeline shader stage create info. So those have already been defined. There's 2 of them. We're passing them in right here. Then we pass in a reference to the create info structs that we made for the fixed function stages back in episode 9. So pipeline info, P vertex input state, which is going to be our vertex input info, pipeline info, and it's P input assembly state, and that's going to be input assembly. Everything's coming together. It feels good. Alright, next up we have pipeline info, and it's P viewport state. Pass in viewport state. You probably get the gist here, but I'm still going to say it all. Pipeline info, P rasterization state is rasterizer. Pipeline info, multi-sampling state equals multi-sampling. And last up, pipeline info, P color blend state equals color blending. Alright, and after that we make a reference to the pipeline layout. So pipeline info, layout, can't spell but that's okay, the computer can, and pass in pipeline layout. And then we have to get a reference to the render pass, and we're going to pass in an index for the subpass as well. So pipeline info, render pass equals render pass, and pipeline info, subpass. And like I said, this is an index, so we're just going to pass in 0 because we only made one subpass, and that'll give us the first one. Let me get rid of that white space. That wasn't necessary. And now we have everything we need to create the graphics pipeline. So let's actually create it. We're going to hop over to the .h file again, scroll down, and just underneath the pipeline layout, we're going to make another vdeleter, and this is going to be a VK pipeline. We'll call it graphics pipeline. Remember that you can have other types of pipelines, so we should be specific. Pass in the logical device and the destroy function, which is going to be VK destroy pipeline. And then we need to call a create function using that, so back over to the CPP file, and just like always, make an if statement, and it's going to be if vk create graphics pipelines, and we're going to check whether or not it equals vk success. And for its parameters, we're going to pass in logical device, and then there's some additional fields here, but we're going to not worry about those too much. They involve creating multiple pipelines. This is the pipeline cache. We're just going to say vk null handle. Next up, we have the create info count, which is 1. We have the pipeline info, so pipeline info. Now we have the p allocator, which as usual is null pointer. And then we're referencing the graphics pipeline, and we have to call replace because we are using v-deleter. But I'm happy that we are, because it definitely simplifies some things. And as usual, if it does not equal vk success, we're going to throw runtime error, and we're going to say failed to create graphics pipeline. And if it succeeds, we will see out. Let's keep this pretty. Graphics pipeline created successfully. And let's not forget to do a end line like last time. Beautiful. Alright, and that should be everything we need. So let's go ahead and give this one more run and see if we can get a successfully created. I spelled graphics wrong. I'll fix that as soon as it ends. Let's see if our graphics pipeline gets created. Just give it a moment. It booted up a lot faster that time, or at least it felt faster. And there it is. Graphics pipeline created successfully. But it's being created, so we have everything we need to get started rendering. Let me just fix this typo. There we go. So that's pretty much it. That's all for this episode. In the next episode, we're going to be actually getting something online, like visibly on the screen. What we're going to do is we're going to start setting up the frame buffers in that one. Frame buffers, command buffers, and then finally get around to rendering. It's going to be exciting. We're finally going to see some output and feel like all this work was worth something. So, as always, thanks for watching, and leave a comment if you have any questions, and subscribe if you would like updates whenever I release a new episode. Thanks for watching.